All right, so get this. Researchers over at ByteDance, they just cracked the code on something pretty huge in AI video generation.
Oh.
Yeah, we're talking about creating high-def videos in real time.
Yeah.
Like no waiting around for rendering and stuff.
Yeah.
It's all thanks to this new model they came up with. It's called a Seaweed-APT.
Seaweed-APT.
Yeah, you ready to kind of unpack this whole thing?
Yeah, this is seriously next level stuff. The paper, it really dives deep into how they tackled this this major speed bump in diffusion models.
Right.
You know, those AI workhorses.
Yeah.
They're known for making really high quality videos. But man, they're slow.
Yeah, I remember reading about those. They basically work by first like corrupting an image or a video with just tons of noise.
Right.
And then they train a network to reverse that whole process, right?
Exactly. It's like, imagine you take like a perfect picture
Okay.
and then you just turn it into static, just like pure noise.
Yeah.
And then you teach an AI to like meticulously put it back together, like pixel by pixel.
That's crazy.
So the results are amazing, but all
Right.
those steps take a lot of time and a lot of computing power.
So how did this ByteDance team, like how did they speed things up? The paper mentions one-step generation.
Right.
What is the magic behind that?
So that's the real breakthrough here. Instead of having to go through all of these multiple denoising steps, Seaweed-APT, it just generates this high-res video in a single pass.
Oh, hold on.
We're
In
talking
one step?
One step.
Okay.
1280 by 720 resolution at 24 frames per second.
Wow.
Instantly.
That seems almost impossible. Don't these diffusion models, like, don't they rely on this whole iterative process
They do.
to get good results?
Yeah, and that's where things get really interesting. So the key here is this new technique that they've developed. It's called Adversarial Post-Training, or APT. It's like a totally different way of approaching this this speed up for diffusion models.
Okay, I'm all ears. How does APT work?
So think about typical acceleration methods. They use like a teacher-student setup where you have a smaller student model and it's learning from this larger pre-trained teacher model.
Right.
But this comes with a really big cost. Generating all those teacher samples is computationally expensive.
Okay.
And it can actually limit the quality of the final output.
So APT just ditches the whole teacher-student thing.
They do.
How do they train the model then?
So here's the really clever part. They start with a pre-trained diffusion model.
Okay.
But instead of using it as a teacher to generate data for a student,
Right.
they directly train this pre-trained model on real data.
Interesting. So they're essentially taking a model that's already kind of learned like the basics of diffusion, and then they're just giving it this like real world experience to sharpen its skills.
Exactly. It's way more efficient. It's a way more efficient way to train, and it allows them to potentially even surpass the quality of the original teacher model.
All right. I'm starting to see why this is such a big deal. But let's get down to the nuts and bolts.
Okay.
How is Seaweed-APT actually structured?
So it follows this this classic generator discriminator framework that we see in a lot of these generative AI models.
Okay.
So the generator, its job is to create the video.
Right.
And the discriminator, it acts as like a critic, learning to distinguish between between real and generated videos.
So I'm guessing APT comes into play somewhere in this this setup.
You bet. It's deeply integrated into both the generator and the discriminator.
Ooh, okay.
So let's start with the generator. Remember how we talked about APT starting with a pre-trained diffusion model?
Yeah.
They use that model to create sort of like a rough draft model. It's called a consistency model.
A rough draft model. What's the purpose of that?
So it's a brilliant trick, and it basically stabilizes the training process. This consistency model, what it does is it predicts what the larger diffusion model would generate. And that gives the generator like a head start.
Oh, okay.
And it prevents it from going completely off the rails.
So it's like having a sketch artist that quickly outlines the composition of a painting before the master artist comes in and adds all the detail.
Exactly. Now let's talk about the discriminator.
Okay.
This is the critic in our artistic duo. This is where things get really technical. They've given the discriminator some serious upgrades to handle the demands of one-step generation.
I'm ready for the deep dive. What kind of upgrades are we talking about?
So first, they equipped the discriminator with a full-depth a pre-trained transformer.
Okay.
So these transformers, these are the powerhouse models behind a lot of the recent AI advancements.
Right.
They're especially good at understanding relationships between different elements in data, which is perfect for analyzing complex video content. It's like giving your art critic a PhD in visual analysis.
Okay, that makes sense.
No.
But I'm guessing a super smart discriminator, like that alone isn't enough.
Yeah.
Right. To make one-step generation work, right?
Yeah.
What else did they do?
They needed to boost the discriminator's learning capacity even further.
Okay.
So they added these extra cross-attention layers
Okay.
throughout the network. Think of them as attention boosters,
Right.
helping the discriminator pick up on these subtle features and nuances
Okay.
that might otherwise be missed.
So they've got this superpowered discriminator.
Yeah,
But how do they make sure that it doesn't get overconfident
right.
and like derail the whole training process? I remember the paper mentioning something about R1 regularization.
Ah, yes, the R1 regularization. This is crucial. It acts like a safeguard against the discriminator becoming too confident and just dominating the whole training process. Think of it as a way to keep the critic
Right.
from getting too big for their britches.
Okay, so R1 regularization is like a reality check
Yeah.
for the discriminator. Make sure it stays grounded
Mm-hmm.
and doesn't become like too harsh in its judgments.
Yeah.
But didn't the paper say they had to come up with like a special kind of R1 regularization?
They good.
Why is that?
So it turns out that standard R1 regularization was just way too computationally expensive
Gotcha.
for their massive transformer model.
Okay.
So they had to come up with an approximation.
Approximation. How does that work?
So instead of using this standard computationally intensive method, they compare the real video data with a slightly noisy version of itself.
Okay.
So this clever workaround, it achieves a similar effect
Oh, okay.
to the original R1. It prevents the discriminator from becoming overconfident.
So they basically trick the discriminator into thinking
Yeah.
it's seeing two different real videos
Yeah.
when it's actually just looking at the same video,
Exactly.
but with some added noise.
It keeps the training process on track.
Pretty ingenious. But with all these complex components and clever tricks, I can't help but wonder, like, how well does this whole thing actually work?
Well, that's the million-dollar question, isn't it?
Yeah.
And the answer is, well, it's complicated.
Oh.
Let's dive into the results
Wow.
in the next part of our deep dive. Trust me, you won't want to miss this.
All right, I'm ready.
Okay, so let's talk about how Seaweed-APT actually performed.
Okay.
The results, they paint kind of a fascinating picture.
All right.
They showcase both the model's strengths, but also areas where,
Gotcha.
it could be improved.
So is this one-step generation all it's cracked up to be?
Right.
Did they manage to achieve, high-quality A&D real-time speed?
On the visual fidelity front,
Okay.
they made some serious progress.
Okay.
The videos generated by Seaweed-APT
Mhm.
show a really noticeable improvement in realism
Oh, wow.
compared to previous methods.
Okay.
Details are crisper, the lighting looks more natural,
Mhm.
and the overall impression is just, more believable.
That's pretty impressive. Do they have any examples of this in the paper? Like, what kind of videos did they actually generate?
They do. They tested Seaweed-APT on several data sets, and the results are pretty striking.
Yeah.
For instance, they were able to generate videos of animals in motion, like a bird taking flight
Well, wow.
or a cat leaping. And the level of detail
Wow.
and smoothness is pretty remarkable.
That's what I'm talking about. But you mentioned that it's kind of a complicated picture.
It is.
What are the downsides? Like, where does this model kind of fall short?
So the trade-off, at least for now, seems to be in what they call structural integrity.
Structural integrity.
Yeah. Basically, while the overall visual quality is really high,
Okay.
sometimes the objects in the videos,
Mm-hmm.
they look a bit distorted
Okay.
or they don't move quite right.
So it's like the model nailed the photorealism, but the animation itself
Yeah.
still needs a little work. Kind of like those early CGI movies where everything looked a bit
Yeah,
too smooth and plasticky.
that's a good analogy.
Okay.
And another challenge they faced was in aligning the generated content
Right.
with the text prompts that we used to guide the model. Sometimes the generated video,
Yeah.
it didn't quite match what the text described.
So it's like the model has a good eye for visuals,
Yeah.
but it struggles with the finer points of storytelling.
Mm-hmm.
I wonder why that is.
It could be that by squeezing the entire generation process
Yeah.
into a single step,
Okay.
that it limits the model's ability
Yeah.
to handle those complex relationships between objects and actions.
That makes sense. It's like trying to write a novel in one sitting.
Right.
You might get some brilliant passages, but the overall narrative, might lack coherence.
But to really understand the inner workings of this model, the researchers went beyond just looking at those final outputs.
Right.
They conducted a series of ablation studies.
Ablation studies.
Yeah, which are basically like controlled experiments designed to pinpoint the role of each component.
Okay, so detective mode activated. What did they learn from these ablation studies?
Well, first, they confirmed that their approximated R1 regularization was absolutely essential. Yeah. This is the trick that they use to prevent the discriminator from becoming too powerful.
Yeah.
When they removed it, the training completely fell apart.
So their clever workaround really was the key to keeping that discriminator in check.
Yeah.
What else did they uncover?
So they found that the depth of the discriminator had a huge impact on the results. The deeper the discriminator, the better the quality of the generated videos.
So it's like saying the more experience an art critic has, the better they are at judging a piece of art. But wouldn't a deeper model require a lot more computing power?
It does. There's always this trade-off between model complexity and computational cost.
Right.
But the researchers, they were able to leverage recent advancements in hardware and software to train these massive models efficiently.
Interesting. So they pushed the boundaries of what's computationally feasible to achieve these results. What about those cross-attention layers we talked about earlier? Did those make a difference?
Those turned out to be crucial as well.
Okay.
So the ablation study showed that removing them significantly decreased the quality of the videos. This confirms their importance in helping the discriminator focus on the finer details.
So it's like saying that attention to detail is just as important as overall knowledge when it comes to being a good critic.
Exactly.
What about training with a large batch size? Remember that being mentioned in the paper?
Yes, using a large batch size that was essential to prevent the model from getting stuck in this rut, generating the same limited outputs over and over again.
Okay.
A large batch size exposes the model to a wider variety of data, encouraging it to be more creative and to explore a broader range of possibilities.
It's like the difference between practicing scales on a piano and actually playing a piece of music.
Right.
With, diverse melodies and harmonies. What a fascinating glimpse into the inner workings of this AI. But I'm still curious about how they actually managed to cram this entire diffusion process into a single step.
So to visualize what was happening inside the model, the researchers used this technique called feature visualization. It's like peering into the mind of the AI, seeing how it's processing all this information and generating that final video.
Okay, I'm hooked. What did they see?
What's really fascinating is that even though the model generates the video in a single step, the process is actually quite similar to the multi-step process of traditional diffusion models. It's just happening all at once in parallel.
So it's like the model is playing all the notes of the song simultaneously instead of hitting them one by one.
Exactly. The shallow layers of the model focus on constructing that basic structure of the video, while the deeper layers progressively add details, all in one go. It's a remarkable feat of computational efficiency.
I'm starting to understand why this research is causing such a buzz. They managed to generate high-quality video in real time, which has never been done before.
It's true.
But you mentioned earlier that there are still limitations.
Yes.
And open questions.
Right. So while they did achieve real-time generation, they were only able to train the model to create videos up to 2 seconds long. Scaling this up to longer videos, that presents a whole new set of challenges. And of course, there are still those issues with structural integrity and text alignment that need to be addressed.
So it's like they've invented this super fast sports car, but it can only drive for a short distance before needing a pit stop. Still, it's a huge step forward, and I can't wait to see where they take this research next.
Me too. It'll be interesting to see how they tackle those limitations and what new possibilities this technology will unlock in the future.
For sure.
But for now, let's shift gears and maybe explore some broader implications of this research. Ready for a deep dive into the future of video creation?
Let's do it. Okay, so we've got this AI that can make real stick videos, like super fast. What does that actually mean for, the real world? Where do you see this technology going?
Ooh, that's where things get really exciting. The potential applications of this technology, it's just mind-boggling. Just think about the creative industries.
Mm.
Film, animation, video games. This could completely revolutionize how those fields work.
Yeah, the possibilities are endless. Like filmmakers could create these complex visual effects like instantly in real time. Animators could bring characters to life with just like crazy detail. And video game developers, they could build these immersive worlds that react immediately to player choices.
Exactly. It's not just about making things faster or easier. It's about opening up a whole new realm of creative possibilities that were just unimaginable before.
And it's not just limited to like, professionals.
Right.
Think about like everyday content creators. Anyone with a smartphone could potentially create these high quality videos that like, could rival professional productions.
Absolutely. It could democratize video creation, giving everyone a voice and the power to tell their stories in a visually compelling way. We could see this like explosion of user-generated content that's more diverse, creative, and engaging than ever before.
I love that idea, breaking down those barriers and giving everyone a chance to share their vision with the world. But let's zoom out a bit. Beyond entertainment and content creation, what other fields could be impacted by this technology?
Oh, there's so many. Education, for one. Imagine students creating these interactive video presentations that just bring their learning to life. Or think about the potential for VR experiences, virtual reality experiences that are truly immersive and responsive.
That would be a game changer for education. It could make learning so much more engaging and accessible. What about fields like healthcare or scientific research? Could this technology have an impact there?
Definitely. In healthcare, it could be used to create these realistic simulations for training surgeons or to visualize complex medical data in a way that's easier to understand. And in scientific research, it could help scientists create models and simulations of complex phenomena, potentially leading to new discoveries and breakthroughs.
Wow. We've gone from creating cool videos to potentially revolutionizing entire industries.
I know.
But with all this potential, it's hard not to, not to think about the potential downsides as well. We talked about the model's limitations, but what about the broader societal implications of this technology?
Yeah, that's an important point. As with any powerful technology, there are always risks. One concern is the potential for misuse. Imagine this technology falling into the wrong hands and being used to create, realistic deepfakes for spreading misinformation or propaganda.
Yeah, that's a scary thought. It highlights the need for safeguards and ethical guidelines as this technology becomes more widespread. We need to make sure it's used responsibly and for the benefit of society.
Absolutely. It's crucial to have these open and honest conversations about the potential risks and benefits involving not just researchers and developers, but also policymakers, ethicists, and the general public.
We need to be proactive in addressing these challenges rather than waiting for problems to arise and then trying to play catch up. It's a responsibility we all share.
I agree. But let's not let the potential downsides, overshadow the incredible potential for good that this technology holds. It's a tool, and like any tool, it can be used for both positive and negative purposes.
It all comes down to how we choose to use it. And that's a conversation we need to start having now before this technology becomes so pervasive that it's out of our control.
This deep dive has been a wild ride, hasn't it?
It really has.
We've explored the technical intricacies of Seaweed-APT, delved into its potential applications, and even touched on some of the ethical implications.
Yeah, it's been mind-blowing to see how far AI has come and to imagine what the future holds. Real-time video generation is no longer science fiction. It's becoming a reality. And the possibilities, they truly are endless.
I hope our listeners are as excited about this technology as we are. It's a time of incredible innovation and discovery, and it's up to all of us to shape the future in a way that benefits humanity.
So to our listeners, stay curious, stay engaged, and keep asking those tough questions. The future of video creation and perhaps even the world is in our hands. Thanks for joining us on this deep dive, and until next time, keep exploring the frontiers of knowledge.